Okay, so the next thing that we're going to be looking at is going to be, and I'm going to go up to the learning plan here. We're in session number 3. So we already talked about shafts. Now we're going to start talking about just doing a bearing design overview. So I believe it was module, I know I'm probably going to, I think it was module 4 when we did, oh no, I think it was actually module 3, we did bearing design. And in bearing design, we did have a spreadsheet that was available to us. So you'll notice that I have a new one populated here. It has gearbox in front of it. And this is a spreadsheet that actually has all 6 bearings that you're going to be incorporating on one spreadsheet. Okay. So since you have 2 bearings on the input, 2 bearings on your jack shaft, 2 bearings on your output shaft, then we have 6 bearings that we're going to be doing. Again, just putting them all in the same spreadsheet so that they're easier to look at. You'll also notice here that there are some Fafner catalog pages. That's where we're going to pick out, just like we did for module 3, the actual bearing that we're going to use. And then there's the fit pages that we need to be aware of too, so that we can incorporate those into our design. So we'll be looking there as well. So, so if we go out to our assignment sheet, you're going to notice that our bearings, the things, those very same things are here as well. So I tried to put them in both places so you're not looking too hard for them. So let's open up and look at the spreadsheet so you can see how it's a little bit different than the one that we used in module 3. So I'm going to do an open and browse to my downloads. Did I open up the same one? Maybe I did. Open, browse. Oh, I think I might have. There we go. All right, so here is the design of ball bearings for your gearbox design. And you're going to notice here, I tried to use the same colors that we did on our shaft design. So the very first input shaft, you're going to have 2 bearings. You're going to have one at point A identified on our layout, and then at point C, okay? Then you're going to notice that we have the jack shaft. That's going to be point D and point G. And then lastly, on our output shaft, which is the green one, you have point F and J. Now for each one of these, it's really the very same little spreadsheet. I'm gonna zoom in and we'll look at it. Okay. So this is just one side. Zoom out just a little bit. This is just one side. So you're gonna notice here that down the middle, you're gonna have your reactions at the bearing. These reactions come from MD solids, okay? These reactions come from MD solids. Remember how when we did MD solids, we expanded out the reactions and you would have the 2 values there? So now what you're gonna do is you're gonna use, and I call it an X and a Y, only because those 2 orientations are 90 degrees to one another, just like we did it for our shaft design. So you're gonna put your 2 reactions in there because there's gonna be one in one direction, one in the other, okay? And then what it's going to do is it's going to determine right here your radial force. So it's going to be the hypotenuse of the 2 legs of a right triangle. That's what you have. Then you are going to put your rotational speed in and your design life. Okay, that comes from your specifications and what you're assuming about how much this is going to be running. Okay, you're the designer. And then it's going to calculate for you your design life, then your dynamic load rating, and your static load rating, okay? These 2 load ratings then are going to be used to size the bearing based on loads, okay? So if we go back to our assignment or the learning plan, you can download this catalog. Wonder if I should have downloaded it instead of clicked on it. Maybe it'll, oh, here it comes. This should look familiar to you. And the last 2 columns here are the static load rating and the extended dynamic load rating. You need to size so that both of those values are in those are for that bearing, right? Remember, so we had to have at least, so whatever you get for usually your dynamic load rating is going to be the one that dictates the design. You have to be sure that in this last column, whatever that number is, that you're going to go over to the left and you're going to check your static load rating as well. Okay, and make sure that it meets both. Now, once you get that, you're going to go over to the bore column. Okay, as we look at our bearing, our bore is right here. This is the part that's going to be on our shaft. Okay, that's going to be on our shaft. So on our spreadsheet, you're going to notice I added then a shaft diameter. So what is the nominal, not the minimum shaft diameter? What is the nominal that you bumped it up to? That seems like it's going to make sense. Once you know what that number is and you compare it to what you picked on your loads, which one do you think you're going to pick? The larger or the smaller of the two? The larger of the two. The larger of the two. So then what I'm going to have you do is I'm going to have you fill in who's your vendor. So it would be, I think, Fafner or McFafner. What's the part number? The part number is going to come from the first column right here. Okay. Then you're going to notice that I want you to fill in your basic load rating. Okay, or your basic your dynamic load rating, and then your static load rating from whatever you picked right here. Okay, what is the nominal bore? This is how I know that you checked that it met at least the shaft. Okay, and then you're going to have your outside diameter, your nominal outside diameter. If we go back to here, the outside diameter is the capital D. Capital D is going to be that second column. What is that outside diameter? I think I have you guys doing the width. That's going to be your C dimension right here. It's going to be the C. And then you need to determine what your shaft mating limits are going to be and your housing mating limits are going to be. Those come from back a level, bearings. Those are going to come from these last two charts, okay? These are the green charts. I'm going to click on one of them, the shaft. And these are going to be then the tolerances that you're going to put on your shaft where the bearings are going to mount, okay? So you're going to find your number in the left-hand side, remember, and then you're going to go over, you're going to read these and determine which you are, or which condition you are. Normally you're in the first set, okay? And then it's going to give you your shaft diameter, maximum, and minimum. And you want it in inches because we're dealing with English units here, okay? And that's going to be for the shaft. And then the second one is going to be, you also need to add for the housing. So that's going to be, this one is going to be the housing. We're not worried so much again about the housing. We have the shaft, but I want you to know where to find those because you would need those at that next level of the design process when you start really putting it into something. And so here again, you're going to find your part number on the left-hand side, and then you're going to be choosing which one of these columns you're going to be in, and then housing bore, min, and max. They've got it figured out for you. Okay, you always want to use manufacturer's data when they provide it like this, so that you know that it's going to meet the expectations. Okay, so as we look at our spreadsheet, then those are the last two items that you're going to do for each one of these bearings. So I'm gonna go back out here again and kind of show you. So again, the top one is the two bearings on the input. Middle is going to be two bearings on the jack shaft, and then the two bearings on the output. Now, something that students try to do, and it's a great idea, but it's not required, and sometimes it causes more problems than what it's worth. You don't have to try to have the same bearing for all 6 bearings. Don't have to. All right. That is not a requirement of this class. It's about sizing and going through this process. Okay. Out in industry, it's always nice to try to minimize the number of parts that you have. But like I said, it can make the design process a whole lot longer when you try to make that all work. Okay. So, so don't feel like that's something that you have to do. If you want to do it, great. And if it works out, wonderful. But I wouldn't go through trying to make it work. All right. All right, so so that's going to be the spreadsheet then that you are going to be filling out. Now, if I look back at the assignment for this one, for bearings, I'm just going to go one more time, try to do the back. You'll notice that there is nothing else to do for bearings. It's just the spreadsheet, okay, filling out all the fields for each one, okay? So there's no extra, you know, scans to do or pictures to upload or anything like that. It's just filling that all out, using the information, and then making sure that you check the size based on loads, but then also your minimum shaft diameter bore, and that you're accommodating both of those, and you pick the larger of the two. If your loads require you to have a larger diameter at that shaft, guess what? You've got to put a larger diameter at the shaft, okay? Or if your bearing requires you to have a larger bore because of the minimum shaft diameter, then you've got to bump it up because of that, okay? Because you always have to meet the minimums for either one, okay? All right. Now, if your shaft diameter ends up dictating, or I'm sorry, if your bearing ends up dictating, then you might find that that diameter gets large at your shaft, and all of a sudden you might have to step up all of the other diameters. That's the design process, okay? So this is all about seeing how every step along the way, you've got to go back and see how it affects other things, okay? That's very typical of what you get to do when you get out in industry. Aren't you excited? I'm excited for you. It's fun. Right, Ryan? It is. It really is. Okay. Any questions bearing wise? Bearings are, I'm going to tell you, once we get past gears and shafts, it's like smooth sailing. Okay. There's just it's kind of like the frosting. What? It wasn't. It wasn't. But it's true. It's true. It gets a lot less. The bulk of your design work is in these main, elements. It's in the shafts, it's in the gears. Okay. So, so yeah, bearings, keys, the locational elements, they all get a little bit shorter and less. Okay. So that's all that I have for the overview for the bearings. Okay. So, I'm going to ask one more time, any last minute questions that anybody has? Okay. These are due on our, last day, which I think is, March 1st. I have the due date, but remember, you still get a 7-day grace period. So don't freak out. There is a lot due that day, but it's only because so many things depend on like downstream items to actually get done. Okay. So I'm going to stop recording, and then you're just going to let me know if you need me.